Hello everybody, welcome back to From Rhythm to Algorithm Part 41, Solution and Resolution. Alright, in mathematics we solve things, in language we resolve things. Picking right back up from the last episode, we ended with two physical observations, or mathematical articulations of physics, one being color was a function or proportional to temperature, that color was a function or proportional to structure. So we're just going to keep exploring that idea, keep trying to develop our physical proof. But remember, right, we're all out here observing the same thing. All scientists are trying to articulate the correct understanding of the world around them. All I'm doing is literally taking the sentiment of the species and piecing together logical linguistics things from just different sections of science. Literally all I'm doing. So what we're going to do is just start with a direct physical observation and then go from there. Physical observation. There are three discrete iterations to a shadow. Any object, look at its shadow, there are clearly three discrete iterations. No one can deny that, no one can debate that. And now our goal, to determine a convincing argument and definitive proof of the number of colors. Google it right now, how many colors there are. Why isn't there a definitive answer? Well, because it's an unknown, right? In mathematics, you have x and y variables, different numbers. In physics and linguistics, you just have shit people have not solved yet. And basic fundamental question, everyone logically knows what you're talking about. Everyone in the physical world knows what you're talking about. So why is there not a definitive geometric physical argument as to how many colors are there? So that is our goal, to figure out how many colors are there. If you Google it right now, it will say red, orange, green, blue, yellow, indigo, and violet. That's 7 colors. But just strictly, we'll be going through a lot of physics, math, linguistics, chemistry, and music in this episode. But just linguistically, literally just looking at those words. Indigo and violet are forms of purple. So I would conjecture there are 6 colors, right? The 3 primary, red, yellow, and blue, and then the 3 secondary, don't even have them up here. Now that's the linguistics, just literally looking at the linguistics that exists now. But the reality is these are words describing the physical spectrum. Just go look up the visible spectrum and have a little graph or picture in mind. But the goal is to describe that. And how many discrete, unique colors are there? Well, we've made some other statements like, right, there's one basis, everything's connected, there's no closed systems. So consistently, logically, there are no closed systems is the same as saying there are only open systems. And now, inflation was rapid, inflation was rapid, that's when everything got a lot bigger. Things cooled down. You know, now we live in 3 dimensions, all measurements are in 3 dimensions. And so in the last episode I said we need a better definition for dimension, or I need to do more research. So the functional definition I have is a dimension is a path of movement. So why do I see 3 there? Structure reflects momentum or light. Again, trying to figure out the right word. Reflection, right? Everyone knows what that is physically. But is the right? Pretty sure the word's momentum. Haven't proven it yet. Pretty sure the answer is not light. How about concavity and cavity? Right? We've talked about holes, black holes. Why not black cavities? A cavity is a hole. Concavity, right? Concave up, a parabola like this. Concave down. Right? Those clearly look like U and N. So we can apply concavity to language. But there should be, like, 2 is less than 3, just because from some simple fact like that, we should be able to have, you know, a concave up or down. I think there's just one concavity. So those are the physics I wanted to talk about. Mathematics, right? 3 prime numbers. I've proven that. Every other number above 9 is an iteration of the numbers between 1 and 9. Only 3 prime numbers. Fundamental stability of 2 is the only difference between sequential prime numbers is 2. We've talked about the max spherical packing density of 68% and 74%, which is again still the resolution to the cosmological constant conundrum literally right now, and it was 3 years ago. The Hairy-Ball theorem. I don't think I've talked about this in the lecture series, but I'm again doing all this off the top of my head, no real notes. The Hairy-Ball theorem, physically, will take like cowlick when you wake up in the morning and your hair's in a weird direction, or they'll take literally a hairy ball and say, can you comb all of the hair so it's all flat? That's the physical demonstration. And then the mathematics they say from that is, in a given vector field, there's always a vector that isn't 0. That's a consequence of there are only open systems. Everything connected, everything is a division of vibration, everything is a differentiation of vibration. So that's for sure where the Hairy-Ball theorem comes from, or if you're talking about it properly, it's my Hairy-Ball's theorem. But again, certain on the prime numbers, certain on the spherical packing density. Thought I should talk about the Hairy-Ball theorem, and we can say geometry is the basis of structure. So how does color come from the structure of the end polygons? Let me make sure I'm still rolling. Now in linguistics, just some, again, more observational data I want to talk about. Right, we've been talking a lot about basis and range. You don't speak any words with 10,000 syllables. Right, we for sure speak words with 1, 2, 3, 4, 5, 6, 7 syllables. Trying to somehow apply the iteration of the prime numbers, the iteration of the numeral system into letters, and from iteration, clearly like favorite or favorite from England to America. That's the society, right? Same word, same logical meaning, different use of letters, same syllability. That's literally iteration at the society level. But we have a finite use of words, and I think it's about 26, right? Most people only use 26 words. So that's just, again, a linguistic result from basis being finite and context defining a variable. We've talked about, I'm not exactly sure the difference between a noun and a verb, so let's resort back to some evidence. Affect versus effect. Effect is a noun, affect is a verb. So, again, some linguistical evidence of a fundamental iteration of, with the relationships of nouns and verbs. Syllability and prime iteration. Just talked about that again. How do we take our, again, absolutely certain on the mathematical arguments, how do we extend and apply that to language? Don't know. Sensorality, haven't talked about this in a while, but from rhythm to algorithm. How did we go from rhythm to algorithm? Life, sentience. So, right, do physical systems articulate their motion independent of algorithms? Right? If people didn't exist, algorithms, set procedures to execute a goal would not exist. So the difference between rhythm and algorithm is sensorality. Just wanted to throw that in there. Chemistry. And now I'm not sure if chemistry provides a linguistical, physical contradiction. Here's what I mean. Right? Talked a lot about 6, 7 colors, 7 in a bunch of different ways in previous episodes, but pH is defined as neutral is at 7. Right? A basic solution has a pH 8 to 10 or above 7. An acidic solution has a pH less than 7. And again, clear scientific use of the word base. That's why I wanted to talk about this. Solvent is the base. You have solutes and solvents. Solvent is the base, as proven by every drug ever. Go look at any drug you have, and it'll say, active ingredients, 0.1%, 0.3%, 1%. And the rest of that is a base, and non-interacting, inconsequential molecule. So just pointing that out, talking through stuff. Does this present a contradiction? And again, I just have range is greater than basis in the context of chemistry. What does that mean? And I say does it present a contradiction? 7. Why is the pH 7? It has to be some sort of result of physics. should be some sort of analog to linguistics and mathematics. Again, just talking through that. And then also, just wanted to review the economics example from the Big Beats episode, but considering basis and range in a general scientific sense, $1, you can go to 0, then you've lost 100%. And in physics, we've talked about you can't, move more than 100% of the energy you've stored. So how do we apply the economic result of, less losing can only go down 100%, gaining can go up more than up 100%, right? I would pair that to like multiplication, multiplicity, right? If I take one thing and multiply it a bunch of times, I have a greater than 100% return of that thing, but I still can't lose less than 1. Again, trying to, what's the difference between iteration, division, subtraction, multiplication, addition, I don't know. Music, 3 note durations, and I have 95% up here because I'm 95% certain that's correct. Just thinking through how certain am I on different observations. But again, how 3 note durations, whole, half, quarter. You take a whole thing, you divide it, you get half. You divide it again, you get a quarter. How does that play out in physics? How does that play out in mathematics? How does that relate our operations of division and multiplication? What's the relationship of operation and function? Functions contain operations. So those are my thoughts there. But how about improvisation? Right, I do all my meditations are just improvs. How often do I change meter or beat or key? Not really key, but just different question. If someone's improving and they're playing the same chords, how many times do they have to play that chord, just one chord or one note, until they change? And I think there should be some reflection of 3 and 7 or 3 and 6. Just had that thought now, but it should be reflective again of this overall iteration of stuff. 7 notes, keys, and steps. Right, 7 notes, 7 keys. The wheel of fifths, but how does function and operation and transition and translation affect discrete functions and continuous functions? Right? Physics, everything, there are only open systems, so everything's continuous to some extent. Because of local size, we can have independent systems. So universally, right, 2 is less than 3. Light is 1 syllable. We said light was dimensionality 2. So, right, structure reflects frequency of momentum, which produces color. Those are my thoughts. Those are a lot of observations in different formal structures. Nothing besides known stuff. And I'm thinking there's 6 colors. I think now we can show some sort of complete reduction of iteration. Thank you for watching From Rhythm to Algorithm, Part 41, Solution and Resolution.